Good evening, my name is Aaron and this is our second part of the project. This is Gregory's slide with the original process. This is my slide with the original process. J.J. Thomson's original process in determining the mass of the electron consisted of a series of experiments involving the cathode ray tubes. His experiments showed that cathode rays were composed of negatively charged particles, which he called corpuscles. Corpuscles. He calculated that the mass of these corpuscles was about 1,800 times smaller than that of a hydrogen atom. This led to the discovery of the electron as a subatomic particle. And this is Greg's slide for the difficulties, and this is my slide for the difficulties. Lots of controversy over the cathode rays and whether they were streams of charged particles or disturbances in the underlying electrical ether. The measurement of charge to mass ratio, he needed to measure the charge to mass ratio of all the particles, which was a crucial part in establishing their identity. The deflection of the cathode rays, he had to demonstrate that the particles could be deflected by a magnet. He had interfaces with other ongoing experiments, and they tended to get in the way of other experiments, but the information also helped benefit his other experiments. This is Greg's slide for motivation, and then this is my slide for motivation. His motivation came from his desire to explore the fundamental structure of matter and challenge the prevailing belief that atoms were indivisible. Lots of his experiments held a response and a long-standing controversy regarding the nature of cathode rays, which were produced by ether. Most of his work led him to conclude that all matter contains particles much smaller than atoms. J.J. Thomson became a physicist by default. His father intended for him to become an engineer, but at the time, that required an apprenticeship which him or his family could not afford. That's supposed to say could not afford. This is my slide for the original benefits. His work had many benefits, both in his time period and our time period today. The benefits it had on his time period include his work on the cathode rays had a profound impact on the understanding of the atomic structure and the further development of physics, and was an advancement in the field of science. His discoveries revolutionized the better understanding of atomic structure and introducing the concept of subatomic particles. This is Greg's slide of the modern process. This is my slide of the modern process. The modern process, the process to complete one of his experiments, is actually very simple and doesn't really require many tools or parts. You can just scavenge a tube from an old cathode ray to oscilloscope, apply voltage to the vertical plates, just how this picture shows. You apply voltage on both ends coming from a source, and then you subject the tube to a transverse magnetic field centering the beam spot, and then that is almost an identical replay of one of his experiments. His experiments are way more simple to complete nowadays compared to how they were completed many, many years ago. This is Greg's modern differences. This is my modern differences. Well, just like anything else that happened many, many years ago, it's completely different and way easier to execute in our current world. Technology is advanced and high-tech compared to them. I guarantee the things we have nowadays actually looked like rocket science to them and had zero clue to where to even begin. But if we didn't have all those things forever ago, doing the experiments they were doing, we actually wouldn't have the things that we have nowadays. People like J.J. Thomson actually paved the path for us. This is my slide with modern benefits. He was a huge influence and help with the foundation of the atomic theory, tons of advancements in the chemistry and physics fields, helping produce and improve the electronics and technology that we have in use today. J.J. Thomson was awarded the Nobel Peace Prize in Physics in 1906 for his work on the conduction of electricity and gases, and of course his discovery of the electron. And not many years later, his son ended up being awarded the Nobel Peace Prize as well. This is Greg's slide for the future expectations, and this is my slide for the future expectations. The discovery of the electron and the findings of the mass of the electron has set the stage for a multitude of advancements in technology and science, including things such as the enhanced quantum computing, advancements in electronics, spinotronics, and orbitronics, and one thing that is extremely important, improved medical applications.